Welcome to Math Mini Lessons. My name is Sarah, and in this video, we're going to start breaking down the 6th grade test using a lot of 2024 questions. You can find a link in the comments for this test if you want to take your own practice test. And I will also say that I added questions to this test. I found it online. They took some questions out. So I added some of my own questions to make it a full test. So here's what we're going to do. We're going to let you guys practice taking the test yourselves and then come back and watch this video so you can see how I break it down. It's broken down in 2 separate videos. Video 1 is going to have multiple choice questions from day 1 and day 2. So we're going to have 36 multiple choice questions in all. And then in the next video, I'm going to break down the constructed response questions. So these are the ones that have 1 point, 2 points, or 3 points. So altogether, this test has 44 questions and 54 points. The other thing I'm going to name for you is that for the first day of questions, the first 30 multiple choice, there is no calculator. These are all done by hand. But everything on the second day, we will be using a standard calculator. There's 4 operations because you're allowed to use it on that second day. The other thing that you'll need is a reference sheet, and this is all the information you're allowed to have during the state test. So if you're taking it on a computer, there's a button that has this. If you're taking it on paper, you'll get one of these here, and it has all of these different conversions and formulas for geometry questions like area. So if you need the area of a triangle, or if you're doing if you need to know what certain prisms are, or if you want to know the volume of a prism, they give you 2 formulas for that. So with that, we're going to jump right into the first set of multiple choice questions. Okay, here are the first 2 multiple choice questions, and what we're going to do is I've broken every page into a chapter, and I'm going to show you the answers for every page so you can check off and see how you did. And if you got it right, great. Fast forward to the next chapter. If you didn't, stay on and actually watch how I broke it down to see if that helps you understand the problem in another way. So with that, here's questions 1 and 2. The answers are A and B. Check off. If you have these right, go to the next chapter. If not, stay right here. We'll break it down together. All right, starting with the first one, I will say this is a little bit spicy for most kids at first, because instead of giving you a regular number, they give you a set of numbers in here. And normally I would have seen it written this way. And I'm almost wondering if this would have made a difference if we had just seen these numbers instead of an expression inside. But let's go into it. Let's break it down. A pattern, student formed a pattern in which each term is represented by a sum. The first 4 terms of the pattern are shown below. Which expression can be used to determine the value of the sum in any terms? Okay, so you're looking to see which of these expressions here would give you, if I substituted these numbers for n, I could get the value of this sum here. So that's what I find tricky about this. So for example, with the first one, n squared, you would have to go and say, okay, so if n is 1, we just get 1 on the other side. But if n is 2, and I'm going to show you what why the difference is here. So if we get 1 squared, we just get 1. But if n is 2, like 2 squared, we would get 4. 2 to the second power is 4. But I wouldn't see 4 here. I see 1 plus 3. And again, that's why if you simplify this to 4, you would have the same value 4. That's what I found tricky about this, that I could see kids substituting that first number and not seeing the sum in the second part. But let's keep going. So if n were 3, 3 squared, 3 to the second power, so you're doing 3 times 3, which is 9, which is what you get over here. But if you're looking to see this answer, you're not going to get that. You would just see 9. But this has the same value. There are equivalent expressions, and that's what makes it tricky. And if you get 4 squared, that's 4 to the second power. 4 times 4, you would get 16, which is the value of 1 plus 3 is 4, plus 5 is 9, plus 7, you would get 16. Okay, so there's a lot. That's what makes this a spicy problem. 1 is that you would have to know how to evaluate a number with an exponent, and then realize that this term has the same value as the sum of all of these. right? So I'm going to circle A, and let's prove why the other ones don't work. So for example, 4 times n. Okay, so if I were to just put 1 in, 4 times 1, I would get 4 for my first answer, which wouldn't match this. If you tried with the second one, and when n is 1, 1 plus 3 would also give me 4. So I wouldn't get that first number. And 2 to the nth power, what does that mean? So 2 to the first power, that would just give me 2. So again, none of the other ones would work. A is the answer. Spicy to start off. Very spicy. Let's go to the next one. Which expression represents 5 more than the product of 2 plus y? So these are two different things happening here. So we have the 5 more, so that's telling me I'm adding 5 to the product of 2 and y. So product means I'm multiplying 2 and y. So I can simplify this as, instead of saying 2 times y, I can just say 2y. And I'm doing 5 plus 2y or 2y plus 5. And the only one that matches that is right here, 2y plus 5. Okay. With the first one, notice they added the 2 and the y, so that's what's wrong. It has to be a product. For C, they're dividing 2y. That would be the quotient of 2 and y. And on the bottom one here, it's y divided by 2, so that would be the quotient of y and 2. And notice again, the way I'm saying it, the quotient of y and 2 gives me the order. With the one over here, is the quotient of 2 and y. So there's something about order in there when we're talking about quotients. All right, but that's how we break down this first one. So hit pause and jot this down into your notes. Let's look at 3 and 4. The answers are D and C. Check off with your work. And if you have them, move to the next chapter. If not, stay right here. With number 3, we want to know what is B in this problem. What value of B makes this inequality true? 3 times a number is greater than 12. So 3 times something is greater than 12. So my goal is to get the B by itself. What could B be? If this was just 3 times a number is equal to 12, well, we would just rewrite this as, well, 12 divided by 3 would give us that number B. So we're going to do the same thing here. Even though there's a different symbol, we're going to do the same thing. So I'm going to divide both sides by 3. So 12 divided by 3 gives me 4. And 3b divided by 3 is just going to give me b. Okay, so b is a number. This is how I'm going to read this. B is a number greater than 4. How do I know? Because greater gator is facing him. All right, so B is a number greater than 4. So which of these is true? Only 5 is true. So if I were to put substitute again, so here's my sub. I'm going to put a 5 in. 5 is greater than 4. That is true. That is a true statement. These two would be too small. But what about 4? Why can't I substitute 4? So 4 is greater than 4. Wait a minute. 4 can't be greater than 4. It's equal to 4, so that's why that would also not be true. All right, so for that type of problem, just solve it like it was a regular equation, and then we can substitute to check our work. Let's look at number 4. A coordinate plane can be used to show the distance in units between two locations. The location of Jack's house and the store listed below. So his house is at -7, -8, and the store is at -7, 4. And I want to know what is the distance. So luckily, I know this is going to be in a straight line. How do I know? Because they're both at -7. So what I'm going to do is, let's say we didn't even know that. We're going to sketch on our scrap paper what this could look like. So -7, -8. So from here, I'm going to go to -7. I'm just making it up. And here's -8. So I will go walk to -7, down to -8. So I'm over here. And that's his house. and put an H there. And the store is at -7, +4, so going up. So here's -7, +4. That's the store. I want to know how far it is from here to here. Okay, and they're both at the same place at -7. So I'm just going from here to here. So what I'm going to do is, I know that to get from here just to here, I'm walking down 4. How do I know? Because I'm up here at 4. I'm going down to 0. And I can walk down another 8 to the store. So altogether, my distance is 12. It's 4 plus 8 is equal to 12. That's one way to find this. Another way is, some kids can just look at the two numbers. Like I said, there are different ways of solving these things. There are some kids who would look at this and go, well, I'm just talking about the distance from here to here, from 4 to 8. And they just want to know that distance. So again, they might just draw it in some way. Or they might logically think, well, what's the difference between 8 and the 0? I can see some kids doing this. And they go, well, from here to here is 8, and from here to here is 4. So altogether, their distance is 12. I like both ways. Pick the one that works best for you. All right, hit pause, jot this down into your notes, and we'll move on to the next page. Let's start with 5 and 6. The answers are A and C. And I'm going to jump into A, which is a surface area problem, where we're trying to find the surface area, the area of every single side, and they're giving us the formula. 2 times the area, the length and width, the width and height, and the height and length. And they're giving us all of those dimensions. So they're giving us the length, the width, and the height. Okay, so where does it even come from? Just starting off, like imagine here's a box. And if here's my box, I know that it is 2 inches high, it is 12 inches long, and this is definitely not to scale, 9 inches wide. But their size I can't see. It's a 3D shape, so I can't see the front and back. So this surface area tells me find the area of each of the parts. So we're going to find the area of the front, which is just length and width. Well, in this case, it's the length and the height. And then we're finding the area of the side, and you're finding the area of the top. And we're multiplying it by 2, because just like there's a top, we know there's a bottom that's the same size. Just like we can see this side, we know there's an other side that we can't see. And just like there's a front, we know there's a side in the back we can't see. And that's why we're finding the area of these 3 pieces, and then we're multiplying it by 2. So we're finding every single piece and multiply by 2. So I just wanted to give you that part just so you know where this comes from. Now, what I'm going to do is I'm going to put my formula down. Length, width, width, height, height, length. And all we're going to do is we're going to start putting those numbers in. So length and width are 12 and 9. So 12 times 9. Plus width and height are 9 times 2. Plus the height and length, 2 times 12. Okay? So let's do those parts that are just in the parentheses first. So 9 times 9 times 12 is 108. Plus 9 times 2 is 18. Plus 2 times 12 is 24. So now we've done all the parts. We can add this up together. So 108 and 18. And this is a type of problem where the more organized you can be, the better. So 108, I'm going to put it over here, plus 18. 16, carry the 1. Okay, 126. And 126 plus 24 gives me 150. Awesome. So S is equal, the surface area is equal to 2 times 150. And 2 times 150 is 300. So this one, once you understand what the formula means, then honestly, for some kids, they just want to know the y first. Then you can just sub in the numbers and work it out piece by piece. Do the multiplication, add them up, and then you double it. Let's look at the next one, which is another order of operations type problem where we want to know the value of the expression. So that means I'm going to use my order of operations, and I'm going to write them here on the side. Parentheses, exponents, multiply or divide from left to right, add or subtract from left to right. And yes, it is either one of those two operations from left to right. The grouping ones and then the combining and joining ones and separating. But you'll also notice that there's some other symbols that are in here that you may not normally see. Like we've seen parentheses, but we haven't always seen brackets. What I would tell you is start with the one in the middle first. They're both types of parentheses, so we'll just start in the middle. So I'm going to start by just rewriting it. And then we're going to start with the inside part, which is this part here. And in this part, I have to deal with this exponent first. 4 to the second power, which is not 8. It means 4 times 4, which is 16. So 16 plus 1. Okay? And I'm always in the habit of rewriting everything. I know a lot of kids are like, Miss, why? Why we gotta rewrite the whole thing? I get it. It's just for me, I like to see the problem getting smaller, and I caught that I wrote the wrong number at the bottom. All right, so let's finish off what's in the parentheses. That's 16 plus 1 is 17, so 3 times 17. Now I'm up to here. And 3 times 17 is 51. I'm not going to actually work out the multiplication for you. You can do that part. But I'm getting 51. So now I have this. 2 times 51 minus 2 to the third power. Okay. Let's deal with that other exponent, because now that I've done a lot with what was in parentheses and stuff, I want to deal with that exponent, 2 to the third power. So again, this does not mean 2 times 6. A lot of kids just go, it's multiplying, it's 2 times 6. This is just a quick way of showing repeated multiplication. So this is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay, so now I have 2 times 51 minus 8. We're almost there. 2 times 51 is 102 minus 8, and 102 minus 8 is 94. So done. And again, what I like about this problem is that as I keep going, it gets smaller and smaller and smaller. But I started off with those parts. I started off by doing what was in parentheses first. Well, first I had to deal with this part in the parentheses. Then I did the rest of the parentheses. Then I did the rest of what was in the parentheses until I got to like, this is just 51. So we're good. After that, I dealt with this exponent. After that, I went from left to right. I had to multiply my multiply or divide, and I have multiplying before subtraction. So I did that. And then all that was left was subtraction. All right, so hit pause and jot this down in your notes. There are so many steps here. I would not be surprised if we make a little mistake, but the big key is make sure you have the right order. And look out for those little things that you know you sometimes have to pay more attention to. Like for some people, I got to pay attention to my exponents more. For others, I need to be more careful when I multiply. You know you best, so you know where you have to put a little bit more focus and attention when you're working on these problems. Let's look at 7 and 8. The answers are B and D. Check it off on your work. Keep going if you have these two. If not, stay right here. This first one, number 7, is an RP problem. I have a ratio, a relationship between two numbers. So a bakery makes 9 cakes using 3 bags of flour. The bakery uses the same relationship between the cakes made and the amount of flour. So they always have the same recipe. They're always made with the same parts, even if I'm getting more or less of them. Okay, which value shows the relationship between the number of cakes the bakery makes to the number of bags of flour? So let's just make sure we have this described. We'll make a ratio table: cakes, and flour. And we know that he can make 9 cakes with 3 bags of flour. That's my ratio, but that's not a ratio in simplest form. I can actually simplify this ratio into 3 over 1. And I prefer that one because I might have a bakery that's using the same relationship, but in a smaller number of cakes. Okay? So now with this, I know that for every 3 cakes, they need 1 bag of flour, and that's what I'm looking for. So when I look at the first one, he has 1 cake, 3 bags of flour. That's not the same. Even though there's a 3 and a 1, they're in the opposite relationship. This type of bakery uses a lot more flour for every cake. So no. For 3, I have 3 cakes and 1 bag of flour. So we're starting off good. And then we make another cake. So now I have 6 cakes. I need another bag of flour. And I bake another 3 cakes. I need another bag of flour. So you start to see that these are growing in that pattern. 3, 6, 9, 12, 15. So for every 3 cakes, I'm getting 1 more bag of flour. So you can see what I mean. Every single time I make another one, I have 1 more bag. And here is every time I make 3 more cakes. And that's my relationship. That's what I wanted, and that's why B is the answer. So when I look at number 7, I'm only, let's look at C over here. Here I have 7 cakes. Need a bag of flour. That's not the same as 3 cakes and 1 bag. So if there's only 1 bag, you can only make 3 cakes. We can cross that out. And here for D, he's using, if he has 7 bags of flour, he's only making 1 cake. That's also not. Those 2 are obvious. I can get them out the way. Let's look at 8, which is another ratio problem. A punch recipe requires 2 cups of cranberry juice to make 3 gallons of punch. Using this recipe, what is the amount of cranberry juice needed to make 1 gallon of punch? Okay, so we're doing cranberry juice, CJ, and punch. That's the relationship we want. I'm making another ratio table. So I have 2 cups of juice, and I can make 3 gallons of punch. But I want to know how to make 1 gallon of punch, and I don't know what this number is. So what I'm going to do here is I'm going to rewrite this as an equation. Watch what I'm going to do. I'm going to cross multiply. I'm going to use my cross products to make an equation. So here, 3 times a number is equal to 2 times 1, which is 2. Okay, so some kids, they just do this and they go 3n is equal to 2. Okay, now that is something. How do I figure out what that number is? 3 times something makes 2. So I'm going to divide. I'm going to rewrite this as a division problem, and we're going to divide by 3. Okay, so a number, 3 divided by 3 is 1. So a number is equal to 2 divided by 3. And so that means for every 1 gallon of punch, I need 2/3 cups. And that is D. So this is one way to solve this that I really like. It will always work if you're using your cross products, and then you just have to divide to just get the number that you want. All right, there are so many other ways. So if you have another way that you can solve this, put in the comments, because there are tons of other ways, and I might actually show a different way for a problem like this in this video if another ratio problem like this comes up. Anyway, hit pause, jot this down into your notes. Let's look at 9 and 10. We have A and C. So check off, and we'll jump right into 9. A zoo has 15 toucans and 60 parrots. So as soon as I start seeing 2 different values, 2 different quantities, I'm thinking ratios. There's a relationship between them. And here you go. What is the ratio of toucans to parrots? Okay, so what do we know about toucans and parrots? First of all, they're giving us a ratio. So this is a ratio, but what they're actually saying is, what is the simplest ratio? That's what they're really saying, because they gave us a ratio. They just want one in simplest form. So what we have to do is we have to think, is there a number that I can divide 15 and 60 by? Okay, try and think, is there a number? So some kids do this and they start thinking, what can I divide both of these by? Well, I can divide 15 and 60 by 3. That works. And watch how I can do this multiple times. So 15 divided by 3 is 5. 60 divided by 3 is 20. That's still not in simplest form. But sometimes it takes some kids more than one shot to get there. So now, what can I divide 5 and 20 by? I can divide both of these by 5. And I get 1 and 4th. So this is in simplest form. My simplest ratio is 1 to 4. Now some kids, what if you would have started with 5? Would that have made a difference? Let's see. 15 divided by 5 is 3. 60 divided by 5 is 12. And then I still would have divided by 3 to get 1/4. So see, it doesn't matter which one, as long as you're using common factors. And some kids, if you had seen from the very beginning 15 was the greatest common factor, awesome. Again, lots of different ways that you can do this. Use the one that works for you. All right, anyway. So I have my ratio 1/4. And again, what does that mean? For every 1 toucan, there are 4 parrots. So there you go. I have 1 to 4. Where some kids might get tripped up is they might have it backwards. So remember, it has to be in the order they're asking for, and they want it toucans to parrots. So toucans had to be first and then parrots. So that's why the answer couldn't be C. All right, let's look at the next one, 10. The water level at an ocean bay changes at an average rate of 3 meters per hour. So every hour it changes by 3 meters. At this rate, how many hours would it take to change 12 meters? Okay, so we're talking about meters and hours. Clearly, this is a ratio problem. So I'm going to make another ratio square, and we're going 3 meters for every 1 hour. And I want to know how long it will take to get to 12 hours. Some kids use a double number line for this, and I'll show a double number line as well. But I really just love this ratio table, so I'll do the ratio table first and then double number line. And I want to know this number. So again, I can just cross multiply. So 1 times 12 is 12. And 3 times the number is 3 times the number. And now I want that number by itself, so I'm going to divide by the coefficient. Divide by 3 and divide by 3. And 12 divided by 3 is equal to 4. So 4 is equal to that number. Okay? Some kids, when they see something like this, like 12 is equal to 3 times a number, times something, some kids just rewrite it as a division problem. 12 divided by 3 will equal that number. So again, whichever way makes the most sense to you, use. But I love this method because it is something that we can solve. It is something that we can do. We can find an answer for it. Now, if you want to do a double number line, you could have just done meters and hours. And you could have started and said, when I have 3 meters, I have 1 hour, and gone to the next one. When I have 2 hours, I'll have 6 meters because you're adding on. I have 3 meters, I'll have another 3 hours, that's 9. I have another hour, so 4 hours, I have 12. So that could be another way to actually find this answer. So again, just use what works for you. So we're gonna hit pause and jot this down into your notes. Let's look at 11 and 12. Our answers are B and B. Okay, check off into your notes and stay here if you want to see how I break this down. So this is an inequality, and I want to know which number line shows this inequality. X, and then there's it looks like an angle symbol in a way, but it's not. It's a greater than less than symbol, and that's underlined. So this literally says X is greater than or equal to 3. That's what that says in math language. Okay, so that means X is the number 3, so it can be a 3, and it can be all the numbers that are bigger than 3. So that's what I want you to look at. So it can be 3. That's why we fill in the little space, the little dot. So oops, wrong part. Sorry, and this is supposed to be a negative 3. So it can be negative 3, so it's filled in. So these two have it filled in. These two do not. That means they do not include 3. So I'm going to cross these out. Okay, because they're open, they don't include negative 3. Okay, so again, I want it can be equal to 3 and all the numbers bigger than 3. So all the numbers bigger than negative 3 are all of these numbers. So that's why B is the answer. C has negative 3 and all the numbers smaller than negative 3. So that would have meant that I would have had to say X is smaller. So I would have used a different symbol. All right, and honestly, I have some adults that still get stuck on some of this. So don't worry if you're still grappling with it and making sense of it. It takes time. Let's look at number 12. Arnold's entire workout consists of 10 minutes of warm-up, 25 minutes with weights, 15 minutes on the treadmill. He works out a lot. And we want to know, this is what we have to solve, the ratio of the number of minutes lifting weights to his entire workout. So we want to know from his lifting to the whole workout. Okay, so, and we're probably going to simplify it then. So how much time does he spend just lifting? He spends 25 minutes lifting. And his whole workout, well, he does a 10-minute warm-up plus 25 minutes lifting plus 15 minutes on the treadmill. So all that together is 50 minutes. So 25 over 50. All right, and they're going to ask us to simplify this. And if you're pretty savvy, you know that 25 is half of 50. So this simplifies to 1/2. And there you have it. And again, I needed the 1 to come first because it says the ratio of how much he lifted. So the 1 has to be first because we lifted it. And notice how when I see that direction, I write my ratio in the same way. But the first thing they said and the second thing they said. All right, hit pause and jot this down into your notes. Number 13. Whew, it was not a lucky one. This one was spicy. Not one of my favorites. This was from an older test. We need to figure out the distance of points. And the answer for this one, I will tell you, is C. And this is why. They want to know, so we have 2 points, F and G, which we have plotted. And G and H, and this is again, it's like a reading test. Like they're testing how well you pay attention sometimes, not with the math. So G and H are the same distance apart from F. What could the coordinate for H be? So let's say I started with the first one and I just picked 1, 2. So 1, move over to 1 and up 2. So is this point the same distance? If this was my point over here, let me actually draw it in. So let's say this is H. And they're saying G and H are the same distance from F. So is this the same as this? And honestly, no, it isn't. Even though it looks diagonal, it's not the same. Because I'm going over 2 units and this is going over 2 units and I would still have to go over 1. So nope, this is not the same as that. So that's meant to be tricky. So forget H, that point. Let's go to the next one, 4, 2. So over to 4, up 2. So again, they're asking, is this the same distance as this? No, this is not the same distance as this. The H is super close, so I can cross that one out. And I'm just thinking about it as walking. So let's go to the next one, C, which is 5, 1, which is the correct answer. Over to 5, up 1. So if I'm walking to F, I'm going 1, 2, 3. If I'm at G and I'm walking to F, I'm going 1, 2, 3. They are the same distance away. even if I went diagonally, like through the street, I'm going over 1, 2. And even if I went from here, I'm going over 1, 2. Those are the same distance. And I will tell you, Math Marvels, even it took me a minute to understand because I wasn't paying attention when they said that point H is the same distance from F. I thought these 2 points had to be the same from whatever the other point was. But I hope that helps. This one was tricky and spicy. So let's jot this one down into notes. Let's move it up to 14, 15, and 16. The answers are D, D, and D. All right, check them off in your work. Stay here if you want to see the breakdown. What is the value? So this is an order of operations problem of 8 squared. So I like to start by always rewriting the problem. And if you need as a reminder, parentheses, exponents, multiply, divide, add or subtract from left to right. All right, so we have 2 exponents in here, so we're going to deal with them first. 8 to the second power is 64. First place, some kids will make a mistake. So 4 times, because remember, it is not 8 times 2, it's 8 times 8. And the next one, 2 to the third power, is the same as 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. Okay, so now we've done our exponents. There weren't any parentheses. So now it's the multiplier, divide, or divide from left to right. So we're going to do the division first. Okay, just so you can see how we're starting off. All right, 64 divided by 4 is, I believe it is 26, but let's actually try not to do it in our heads. Just do it on scrap paper. 4 goes into 6 one time. 24, 4 goes into 24 6 times. So there we go, 16. So now I have 16 times 8, and that's the last thing we're going to solve. 16 times 8. 8 times 6 is 48, and 8 times 1, 8 plus 4, 128, which is D. Okay, so big pitfalls here are working with exponents and making simple exponent mistakes, or just mistakes with multiplying or dividing. And remember, it is multiply or divide from left to right, add or subtract from left to right. Let's go to the next one. Ben purchases 1.14 pounds of nuts and puts them into bags. Each bag holds 1/8 of a pound. He uses all the nuts to fill the bag completely. How many bags does he fill? So this is an equal share problem. We're dividing. So 1 and 1/4, and we're dividing it into bags that are 1/8. So I'm just repeatedly sharing it. Okay, so to start off, let's change this to an improper fraction to make it easier. 4 times 1 is 4, plus 1 is 5, so 5/4. If that messes you up, you could also just always take 1 and break it up into 4 pieces. Now you have 4 and plus 1/4. So you can actually see the 4 over 4 and then just add the 1/4. All right, and I'm going to divide by 1/8. I'm going to rewrite this as a multiplication problem. I have tons of videos on this, so please check our folder, our playlist with 6th grade videos if you need to. So I have 5/4 times 8 over 1. So that's my rewrite as a multiplication problem. We're changing it to multiplication and we're flipping the second fraction to its reciprocal. Now I can multiply. 8 times 5 is 40 over 4, and I can change that back to a mixed number. 40 divided by 4 is 10. So just a lot of fraction skills from also 5th grade. So you just take it one piece at a time and work it out. All right, let's go to the next one, which is another order of operations one. This one has tons of stuff on it, and it has a division bar. So if this division bar really bothers you, that fraction bar, we can rewrite it. So watch what I can do. I can say, I know that all this, let me get my lovely little pointer, all of this is being divided by 2 to the 4th. This whole thing. So I can rewrite this with a parentheses as 3 to the second power times 2 to the third power plus 4, closed, closed, and then divided by 2 to the second power. Okay, we're going to start with parentheses and start from the inside out. So we're going to look in this part in here. And before I can do any addition, we got to deal with that parentheses. With that exponent. So let's work that first. 2 to the third power we've done before. 2 times 2 is 4 times 2 is 8. So this is 8 plus 4. And again, I do like to rewrite. So we have this in here. And now we'll do what's inside the parentheses. Again, 8 plus 4 is 12. So I have 3 to the second power times 12 and divided by 2 to the second. All right, now I can't do anything else to that 12, but I know I'm multiplying it by 3 to the second power. So let's fix that. 3 to the second power is 9. So 9 times 12 divided by 2 to the second power. Okay, so that's all I did was I just dealt with that exponent. Now we just scan again. I still have to simplify what's in this parentheses. 9 times 12 is 108 divided by 2 to the second power. And it gets smaller and smaller. Okay, now we can deal with this exponent. 2 to the second power is 4. And we're up to our last step. So I'm going to do my long division here because a lot of kids could get through all that and they want to do the last step in their head. Just stay consistent and do the work. So 4 goes into 10 2 times. And 4 goes into 24 7 times. So my final answer is 27, which is D. So again, what I love about these problems is that they seem very meaty. They seem like they have a lot of steps, but it's really testing our discipline to do things the way we know we're supposed to do it, one step at a time, and to just stay focused. And if you are just rushing to get over with, you are just more likely to make simple mistakes. So just take your time. You have all the time that you need on this test. So take your time and work these problems out piece by piece. All right, hit pause and jot this down into your notes. All right, we're at page 12. So 17 is B, 18 is B, and 19 is D. We'll start off with 17. Pat bounces a basketball 24 times in 8 seconds. So it's definitely a ratio problem. And at that rate, how many times will Pat bounce the ball in 150 seconds? So we have times in seconds. Like how many times did he bounce the ball in seconds? And his original rate was 25 times in 30 seconds. And now we want 150 seconds. So I'm going to do this in a different way because, again, I tell you there's so many different ways we can do this. And you can look for relationship patterns. Like how can I get from 30 to 150 using multiplying? So this is just another method that you can do. So how many 30s would it take to get to 150? Oh, it would take 5. It would have to be, I would have to do it 5 more times. So I can do the same thing up here to the bounceable, with the bounces. 25 times 5 is 125, which is the answer. So again, this is just a third method. Now you have 3 different tools that you can use. You can use these types of it's a multiplicative relationship, meaning as my numbers are getting bigger in magnitude, I can use multiplication relationships to figure out the other number. I can use cross products to figure out the number, or you could have just drawn a double number line and kept on going until you got to 150. 3 awesome strategies that you can use to solve these rate problems. Let's go to the next one. We want to know what is the opposite. And this one's a little tricky in a little way. The opposite of the number -2.5. So let's think about this. It just means if here's -2.5, its opposite would be over here on the positive side, +2.5. See, it's pretty simple, except each of these has to kind of be simplified to figure out the number. So for number 1, we have a negative sign in front of 2.5. So this is still equal to a -2.5. Here I have a negative times a negative. So, oof. Okay. So here's the thing. Even if there's not a number in front, there's an invisible 1 with that negative sign. Okay? So it's like being multiplied by -1. So in the first one, it was like -1 times 2.5 is -2.5. For B, I have -1 times -2.5. And a negative times a negative gives us a +2.5. So that's why B is the answer. In C, you have -2 times 1/2, which is the same as doing, again, -2/1 times 1/2. That gives us -2/2, or just -1. So this is testing. Honestly, this is really testing how you multiply with negative numbers. And the last one is 2 times -1/2, which is the same thing, except now we have the negative on this side instead of the other. So tricky. And at first glance, you think it's one thing, and then you find out it's really about multiplying integers. Okay, let's look at the next one. And you want to find an equivalent expression to the phrase. So we're gonna do it a piece at a time. The quotient of the sum of 2t and 2 and twice the cube of s. All right, so the first thing this is a quotient, so I'm going to be dividing these things. So I'm taking this and dividing it by this. Okay, so the sum of 2t and 2, so I'm adding 2t and 2, is being divided by 2 times the cube of s. That just means s to the 3rd power. Okay, so when I see quotient, I'm taking that first term and dividing it by the second term, and this matches D. Okay, so hit pause and jot this down into your notes. Okay, let's look at 20 and 21. We have C and C. So 20, obviously it's going to be a volume problem. I see a 3D shape, and boom, there's the word volume. So I want the volume of the cube. Because it is a cube, that means that all the sides have the same dimensions. They have the same length, width, and height. So I'm going to do, so you could think of, so you might see this volume is each side to the 3rd power. That's just saying, like, I'm just multiplying 2.5 times 2.5 times 2.5. And is that any different from length times width times height? Same thing. It just means I have the same side, 2.5 times 2.5 times 2.5. All right, so let's change these to improper fractions. So 2.5 is the same as 5/2 times 5/2 times 5/2. All right, 5 times 5 is 25. 25 times 5 is 125. Over 2, and we've done the 2 to the 3rd power so many times. 2 times 2 is 4, times 2 is 8. Okay, so that's my first part. So far, I look and I scan, and I don't see this number here, so it's telling me, ooh, I should probably change it back to a mixed number. So we're going to use division. So remember, we're going to knock this guy over. This says 125 divided by 8. 8 goes into 12 one time. 8 goes into 45 5 times. And my remainder is 5. So I'm going to write this as 15 and 5/8, which, bam, there it is C. Okay, jot that one down into your notes, and let's go to 21. And it says there are 230 calories and 4 ounces of a type of ice cream. So I'm thinking ratio, because I have 2 different things. I have calories and ounces. How many calories are in 6 ounces of ice cream? Okay, so I have calories and ounces. Let's put this in my ratio table. And we have 3 different ways of solving this, so let's think about which one makes the most sense. 230 in 4, and I want to know how many are in 6 ounces. Okay. So some people really like that last one when you looked at a multiplicative relationship. The problem here is, can you think of a number to multiply by 4 to get 6? No. So we can't really use this one so much. Even if you went and did one of these, 230 and 4, if you tried to skip count to the next one, you would skip over to 8. So that may not help you. So if you were doing the table, and I'm going to do the table and I'm going to use the cross products, what you could do is maybe you want to work backwards and think, all right, if 230 is in 4 ounces, how many are in 2 ounces? Like maybe you might want to go and say, what if I put it in half? And if you do that, you might say, okay, well, half of 230 is 115. And I've seen some kids go, well, what if I just added these 2 parts together? If 4 ounces had 230 and 2 ounces had 115, why don't I just add both of these up and I will get 345. So that's one way of thinking that absolutely works. Okay. So again, just so you can see how I got that. If I knew what 4 was, 4 ounces has 230. And if I know 2 ounces has 115, I can just add them up together to get 345. That's one way, does work. If I did my cross products, because that does take a little bit of a leap to figure out the halving and the pieces. If you did the cross products, I know that I'm multiplying this way across and across. So 4 times a number is 4n. And 230 times 6. 0, 6 times 3 is 18. 6 times 2 is 12. This one is 138. Is 1,380. And now I can just divide by 4. So I can rewrite this as a division problem. 4 times the number is 1,380. So 1,380 divided by 4 will give us that number. And if you do that division work, I want to give myself a little bit of space to do it. If we do that division work, I'll do it over here. We still should get 345. Matter of fact, I'm going to give us some space here so you can really see it. So 4 can't go into 1. 4 goes into 13 3 times. 12. Subtract 1. Bring down the 8. 4 goes into 18 4 times. That's 16. Subtract 2. Bring down to 0. 4 goes into 20 5 times. Okay. So there you have it. That's just another way. So you have 2 good ways of figuring this out that really work, and I hope, but we saw that multiplicative didn't really work so much. But that's the great thing about having different ways of doing something. Sometimes what really works in one problem may not work as well in another. So having other strategies can help you. But what I love about the cross products is that strategy will always work for finding it out as long as you're calculating correctly. But hit pause and jot this down into your notes. All right, let's do 22 and 23. 22 is B and 23 is D. We'll start with 22. Tammy and Jacob collected stamps. Tammy has S stamps. Jacob has 4 fewer than 3 times as many stamps as Tammy. Whew. Okay, which expression can be used to find out what Jacob has? So Jacob has 4 fewer. So I know that first part is just minus 4. Then 3 times the number of stamps Tammy has. I know Tammy has S stamps. So he has 4 fewer than. That means I'm going to do minus 4 and the 3S first, okay? Because it's 4 fewer than this number, so it has to come after. All right, I've seen a lot of kids do it backwards and they write -4 plus 3s, and that doesn't make sense. And even here you can see how they have a +4 minus 3s, and the big clue was that we don't have times -3s here. Okay, so that's what makes this tricky. It's knowing that when they say 4 fewer than, this is what they mean. 4 fewer than, that means the -4 comes after the other term. If they just said 4 less 3s, then I would do 4 minus 3s. I would use that term. Okay? All right, jot that one down into your notes. And let me actually make sure people can see that this means 4 less 3s. Okay? Oh, I like this one. This one's converting units. A container owns 6 gallons of liquid. How many pints of liquid do they hold? So you can look at the beginning and go back and look at your reference sheet, and you'll be able to find what that conversion is. Now, if you cannot, I like to use this story to figure out how to convert gallons and pints, because I don't always, in real life, I don't have a reference sheet just with me. And I could just use ChatGPT or my phone, but I don't. I tell myself this story. Story of King Gallon. So King Gallon has 4 queens, and each queen has 2 princesses. And each princess has 2 cats. So if each princess has 2 cats, here are all the C's. I'm going to write 4 of them because each princess has 2 cats. All right, right here, these are all the ratios for gallons, quarts, pints, and cups. All right, so when I'm looking here, I see 1 gallon has how many pints? 1, 2, 3, 4, 5, 6, 7, 8. So 1 gallon is equal to 8 pints. And I'm telling you, that little story just helps me out all the time. So if I know that 1 gallon has 8 pints, then 6 gallons, it's going to have 6 times as many pints. 8 times 6, which is 48 pints. There you have it. All right, hit pause and jot this down into your notes. All right, let's look at 24 and 25. The answers are D and B. Check it off in your work. We'll start with 24, which has a lot of multiplying. So luckily I did it a little bit in advance. And it's a volume problem, and it's a cube. So we know that the volume of a cube, we can usually use volume equals s to the 3rd power, which just means, in this case, 2.3 to the 3rd power, or 2.3 times 2.3 times 2.3. So we're going to do the first ones first. 2.3 times 2.3, and if you do that multiplication correctly, you're going to get 5.29, or 5 and 29 hundredths. Okay, so now we're going to do 5 and 29 hundredths times 2.3, and if you do that, you'll get 12 and 167 hundredths. So the big key here is obviously it's just a lot of multiplication, but multiplying with decimals. So just be careful and recognize as you're multiplying, are you paying attention to the decimals? So what I mean by that is in this first one over here, I have 2.3 times 2.3. I have 2 numbers behind the decimals, which means I need 2 numbers behind the decimals here in 529. So here's 5.29 and 2.3. So now I have 3 numbers behind the decimals. So after I multiplied, I needed 3 numbers behind the decimals over here. Okay? Let's look at the next one. And Omar has 2 3/4 cups of dough to make dumplings. He uses 3/16 of dough for each dumpling. So this is making me think of division. How many whole dumplings can he make? So I'm going to take all the dough, and we're going to divide it by 3/16. Not the friendliest of numbers. Let's start by changing this to a improper fraction. 4 times 2 is 8. 8 plus 3 is 11. So I have 11/4 divided by 3/16. And we're going to change this to a multiplication problem. So 11/4 times 16 over 3. My denominator is friendly enough, but we have to do 16 times 11. Okay. So 1 times 16 is 16, put a 0. 1 times 16 is 16, and I get 176 over 12. Now, you may have already noticed that we don't see that answer anywhere in there. So I have to do some division work. So let's go and do that. We're going to do 176 divided by 12. Can't go into 1. 12 goes into 17 one time. And 12 goes into 56 how many times? Well, I can get 4 times, so that's 48. And I'm going to have a remainder. I have a remainder of 8. So I can't make any more. Okay, so my remainder is not enough to make an extra dumpling, so I can only make 14, which is B. Okay, hit pause and jot this down into your notes. Let's look at 26, which is B, and 27, which is C. 26. What ordered pair represents the location? So I want to know what pair is the reflection of -4, 6 over the x-axis. Okay. So I'm going to start by kind of estimating where that is. So -4, if I'm starting from here, I'm going to go back 4 and up 6. So that's where this piece is. Here's -4, 6. That's what the point is. And I want to reflect over the x-axis. So that's this one here. Here's my x. This is my y. So it's saying I want to flip over this one. So if I flipped over, I would be down here, which would mean I'm at -4, -6. Okay? So what's tricky here is that some kids may have just flipped it over the y-axis, and they would have put it over here at +4, 6. So we can expect that. All right, let's look at the next one. We have a ratio problem, again, because I see ratio tables. The ratio of students to adults in a field trip is 8 to 1. So in other words, for every 8 students, there's 1 adult. So which table correctly shows the ratio for that grade? So we know the answer is C when I'm giving it to you, but here's why. So it's telling me that for every time I know an adult here, if I multiply, each adult has 8 kids. Every adult has 8 kids, and that should tell me how many students I have. So when I do this, 12 times 8 does give me 96. Same thing with 15 times 8. And remember, this is where they're testing you when you're at your most tired. So just be prepared for that. Just know that that happens towards the end. So 5 times 8 is 40. 8 times 1 is 8 plus 4 is 120. And the same thing at the bottom, if you multiply 17 by 8, you would also get 136. Okay, with the other ones, I know it can't be true for A. They didn't multiply by 8. It was looking to see if you just added 8. So that's why that doesn't make sense. And in the second one over here, this doesn't make sense because it just means they actually subtracted 8 to get the other number. And that still doesn't make sense because we have 8 times more students than teachers. And I think the last one is just super random because I don't even know how they got from 11 to 96. So this one's just super random. And I'm trying to think of how they would have got there. They didn't multiply by 9. That would have been 99. But this is like the super random one. But we'll see if you actually multiply the adults, you would see that that ratio stays the same. Okay, so it's just testing to make sure you understand the ratio and how to check it on the table. Hit pause and jot this down into your notes. Almost done with the multiple choice for day 1. We're at the last 3. So 28, the answer is C, and 29, it's B. So let's look at 28 first, and we're figuring out the area of our isosceles trapezoid. So let's actually go and look at what formula they're giving you in your reference sheet. So I'm just going back in. Let's pop it back up. All right, so the formula for area of an isosceles trapezoid. Huh. They're actually not giving it to you. Interesting, interesting, interesting. So what we're going to do is we're going to break apart. We're going to break this up. So we have two little triangles because that we do have a formula for, and a rectangle. And when we break this apart, so I know that this part here from here to here is 10. And I know that the other two sides are going to be equal. Okay? So these two sides have to be the same, and I know this part is 10. So these two parts have to add up to 6. So I know this part is 3, and this part is 3. Okay, so let's start with the area of just a rectangle is 15 times 10. That's 150. The area, area of a triangle, we have 1/2 base times height. And we have two triangles, so we're going to do, and they're both the exact same size. So I have 1/2 times my base, which is 3, so 3 over 1, times my height, which is 15, 15 over 1. So that gives me 45 over 2. And when I divide that in half, I get 22.5. So that's one triangle. This one triangle is 22.5. And that means this other triangle is also going to be 22.5 because it has the same things. And we know the inside part is 150. So now I'm going to add all those parts together. 150 plus 22.5. Actually, let me write it the other way. 150 plus 22.5 plus 22.5. I want to add these two fractional parts up. 22 plus 22 and a half. That gives me 45. And 150 plus 45 is 195. Okay, so like I said, towards the end, it does really push you to see who's just going to pick anything and who's going to, a lot of kids make the most guesses during the last 5 problems because they're very challenging. And students who are usually my 3s and 4s tend to really push at this part because they still believe they know the content, so they continue to take longer and they want to solve it out. I think any kid can work through these problems if you have a strategy and if you're willing to use some of these strategies from the video and keep pushing forward and just not giving up. Let's look at the last one here, 29. The inequality is shown. -9 over 20 is greater than -21 over 24. So let's think of it on the number line. They're both negative, so I know they're both on the left side of 0. So my bigger numbers are always on the right. My smallest number is on the left. This is telling me that this number is bigger than this number. So I'm going to write -9 over 20. And that's here. And then somewhere on the other side is -21 over 24. Okay? And I know that this one is the bigger one. So now using this, I have to find out which statement is true. And when you read them carefully, look at the first one. -9 over 20 is to the left of -21 over 24. That's true. Wait, is that true? No, this isn't to the left, it's to the right. So bam, I can take this off. Second one is -9 over 20 to the right. So yep, it's on the right side of -21 over 24, so that's true. And then the second part, and to the left of 0. So -9 over 20 is on the left side of 0. So yeah, and that's why that's the correct answer. The other ones have some things that are, both statements have to be true. So number 20, we know the first one is definitely false. It's not to the left of -21 over 24, so I can just stop that one. And in the third one, the first part is right, but then it's saying it's to the right of 0, and that's not true because then it would be on this side to be a positive number. All right, hit pause and jot this down. No, Siri. Hit pause and jot this down into your notes. This is the last multiple choice problem on day 1. I'm going to do the next 6 multiple choice problems, but I wanted you to know these are the last multiple choice problems. So let's go through it. The answer for this one is D. Okay, so we have a prism, we have a net, we're doing surface area. And I know that because I have a prism that's flattened out. And how do we find the area? So I need to find the area of every single box. But remember, each of these boxes has a matching partner. What I mean by that is I can see like this box and this box are the same. It's like the top and bottom. These sides are going to be the same. And these parts are going to be the same. Okay? So I'm not going to do double work. I can just figure out those parts. Starting with the top one, 5 times 2 is 10. So this is 10 square inches. So I know this part is 10 square inches. Let's do my greens. 2 times 3 is 6 square inches. And this part is 6 square inches. And for my last one, I have, let's see, 5. Oops, let me get my pointer. I want you in red. I have 5 times 3. So this is 15 square inches and 15 square inches. Okay? And so where did I see that? How did I know this is 5? Because I knew up here this was 5. And how did I know this was 3? Because right here this was 3. So now I have everything I need to add. So I have 20 plus 12 plus 30, which gives me 62 square inches. Okay, and that's it for day 1. Those are all the multiple choice questions that you get on the first day of the test. So I'm going to stop the video here. What I want you to do is you're going to just count back and start looking how many multiple choice questions did you get right, and you're going to give yourself 1 point for every single question. Okay? In the next video, in the next part of the video, we're going to do the next set of multiple choice questions from day 2. And that's 6 more problems, and we're going to add those as well. All right, let's jump into multiple choice on day 2. And on this day, you can use a calculator, but that doesn't mean you don't have to capture your notes. We're not going to just type everything on the calculator. Watch how I use the calculator, but still capture it on my scrap paper. So we'll start with the answers to the first 2. For 31, it's A, and for 32, it's B. So we'll start just like before. We'll start with 31. There are 104 calories in 8 ounces of soda. We want to know how many calories are in 1 ounce. So we want the unit rate. Okay, so what do we know how many calories in an ounce? So calories, and I'm going to put OZ for ounces. And we know that there are, in 8 ounces, there are 104 calories. So here are 2 different ways you can do this. We want to know how many are in 1 ounce. The first way is we could just do cross multiplying, and you would have 8n is equal to 104, and then you would just solve by dividing by 8. So n is equal to 104 divided by 8, which is, I'm just using my special calculator, which should not have had a negative there. 104 divided by 8, which is 13. Or you can find a unit rate by taking that ratio, 104 calories per ounce, and then just turning this into a division sentence, 104 divided by 8, and you would still get your answer, 13. So both of these can work when finding the unit rate. Jot that down into your notes and use whatever you find most comfortable. This next one, we have surface area, but we have a very complicated prism. Jose builds a skateboard ramp in the shape of a right rectangular prism. The net below shows the dimensions of each part. So one thing I want us to see first of all is that we do have some pieces that are the same size, which are these 2 triangles. But all the other pieces have different dimensions, so that's going to be important. So for example, this is 6 by 4, but this is 6.5 by 4, and this part 2.5 by 4. So let's actually write, I like just naming them A, B, C, and D, since we have 2 of them. So for A, I'm going to do 2 5/10 times 4, and I don't need a calculator for that. That is 10. Because I'm thinking of it like quarters. If I had 4 quarters, I'd have $1. If I have 2.5 times 4, I would get 10. So that's for the A part. For B, I have 6 times 4 That's easy, that's just 24. For C, I have 6 5/10 times 4. I'll use a calculator for this. And I get 26. And for D, this one I'm using 1/2 times the base times the height. And I know I have 2 of them. So, and then at the end I'm going to multiply it by 2. So let's put all of these together. 1/2, and the base for my triangles is 2 5/10, and the height, so not this, that's there to trick you, my height over here is 6. So my base is 2.5. So I have fractions and decimals. Let's change them all to decimals just to make it easier. So I have 0.5 times 2.5 times 6 times 2. Okay, so 0.5 times 2.5 . There we go, that's 1.25 times 6 times 2 is 15. Okay, so now I'm going to add all these parts together. 24 plus 26, that's already 50. And then my 2 triangles, oh, let's not forget the 10, that's 60. So I added this, I added this, I added this, and my 2 triangles is 15. And that would give me my 75. So again, see how even though I have to use a calculator, I still have to keep my work really organized so I can follow through. But hit pause and jot this down into your notes. Right, 3 more. 33 is C, 34 is C, and 35 is D. Okay, so for the first one, we have 4 is 16% of what? So again, I can think of a few different ways I can do this. So 4 is 16%. So I'm going to represent my percent as a ratio. 16 out of 100. So I have a part and I have the whole. So 4 is 6%. So I'm going to put that in the same row as 6%. And I'm going to leave this here as what's the number I want to find. So when I'm looking at it this way, I can find a relationship between these two numbers, but I'm not multiplying to get from 16 to 4. I'm actually just dividing. So I could see a relationship of divide by 4 and divide by 4. 100 divided by 4 gives us 25. That is one way we can solve it. If you wanted to do your cross multiplying, it still works. You would just get 400 is equal to 16 times a number, and then you would rewrite this as a division problem. 400 is equal to 16 times the number, so 400 divided by 16 will give me that number, and then you would just use a calculator for that, and you get 25. Same thing. All right, let's go on to 34. A machine produces chocolate at a constant rate, so we got another ratio problem. In 42 minutes, the machine produces 7 pounds of chocolate. So 42 minutes, 7 pounds. How long in minutes will it take to produce 9 pounds? So let's see. Let's put our ratio in again. And I'm doing chocolate and minutes. So in the first one, it says 42 minutes, 7 pounds of chocolate. So 7 pounds of chocolate in 42 minutes, and I want to know how much is to get 9 pounds of chocolate, and my number here. Nope, Siri, I don't want your help. We're going to figure this out on our own. Now, there's not a multiplicative relationship here. I can't go from 7 to 9, but you might notice there's a relationship here. Like from 4 to 7, what relationship do you notice? You could notice I'm just multiplying by 6. And so here you could also multiply by 6. And 9 times 6 will give you 54. So if the numbers are easy enough, sometimes you can see the relationship there, but sometimes you can't always see it. Sometimes it's not there. But if you don't see the relationship very easily, remember you can just cross multiply. And especially since we have a calculator. Oops, let me just erase that one. 9 times 42. So I can just do that. 42 times 9 is 378. So 7 times a number is 378. So I'll just rewrite that as division. 378 divided by 7 will give me what number? 378 divided by 7 would also give me 54. So both of these methods work. Again, use the one that works for you. Here I can see 3 dimensions, so I'm thinking volume. The dimensions of a cereal box is in the shape of a right rectangular prism. So I have my 3 dimensions, and I need to find the volume. Okay, so I'm multiplying all of them. 8 and 1/10 times 4 and 4/5 times 12 and a half. So being that we have a calculator, I would much rather turn these fractions into decimals. For me, it would be easier. So watch how I'm going to do that. I'm going to turn my 8 and 1/10 into 8 and 1/10. My 4 and 4/5. And if you don't know what 4/5 is, you can just do 4 divided by 5 on your calculator. You get 0.8. And 12 and a half, we'll know that's 12.5. Now that I have this, I can use my calculator to multiply, but I want to be super careful by just doing 2 numbers at a time. So 8.1 times 4.8, or 8 and 1/10 times 4 and 8/10, and I get 38 and 8800ths. And now I can multiply. I clear it again because I don't want to have an error. Oops, see, sometimes when I'm writing my numbers on this special calculator, it makes errors. So I get my final product is 486. There's my answer. Now, if you chose to keep it all as fractions, and you could, you would just have to change them all to improper fractions. So you would have gotten 81/10 times 24/5 times 25/2. The denominators wouldn't have been so bad. 10 times 5 is 50, times 2 is 10. But I definitely would have needed, or not that I would have needed, but I would have relied on my calculator to do the last part. 81 times 24 times 25 is 48,600, and then I would have just divided that by 100. 48,600 divided by 100 would have been 486. All right, hit pause and jot this down into your notes. We have one more multiplication problem left. All right, here we are at number 36. A tutoring company charges, I had a typo there, so it should be charges, $25 per hour to tutor a student. How many hours of tutoring will cost $62.50? So this is price per hour. So if it's $25 for 1 hour, how much to get to $62.50? So first, of course, you can look for relationships. I can see this is 25 times bigger, but I can't really think of a number times 25 to get this, and I can't think of a number to get from 25 to $62.50. So I am going to use my cross multiplying here. So I'm going to do 1 times $62.50 is equal to 25 times a number. And now I'm going to rewrite this. 25 times a number is $62.50, so $62.50 divided by 25 will give me that number. And that I can do with my calculator. and I get 2.5. So N is equal to, because we're talking about money, $2.50. Oh, wait, I wasn't talking about dollars here. We're finding the hours. So N was equal to hours. So it is 2.5 hours. And I do have it over here. So even though it is written in fractional form, it's just 2.5. They just changed it to hours, 2.5. And that would have been A. All right, Math Marbles. So that's the last of the multiple choice questions. Now, remember I told you, given all the questions we have here, we have 36 multiple choice. Each one is worth 1 point. So right then and there, that's a big bulk of the state test. So you can have up to 36 points. So use this to actually help practice and study. Again, go into the comments if there are certain questions you have, if there are different strategies you want to share, or even if just saying, I really like this video and I want to learn more, let me know. Or if there are certain topics you want to see, let me know as well. That's it for today. In the next video, we'll do constructive response, and I'll see you in the next one, 6th graders. Bye-bye.